Okay. And also, maybe we can initiate our recording also we can initiate.
Ma'am, I have initiated, ma'am. The recording started, sir.
Okay. We'll start in another 1 or 2 minutes.
Okay.
Greetings and good evening to one and all. On behalf of the organizing units, Computer Society of India, Chennai chapter, IEEE Computer Society, Madras chapter, and ACM Chennai chapter, I extend a warm welcome to our today's speaker, Professor Gautam, participants joining the Google Meet and YouTube streaming, my colleagues from the organizing units. Data is the new oil. Its power is growing exponentially. It is deciding the growth and survival of an organization in the digital dominated current environment. Data is fundamental to make informed decisions in everyday life of an individual to organizations. How and why data is perceived to be having such an important role in today's economy. Today's presentation is all about a detailed discussion on this by a seasoned teacher and speaker, Professor Gautam. We are aware that we all need to make informed decisions, both at work and in our personal lives. For that, we need to gather good data, make suitable assumptions, analyze the data, build models, make predictions, test, verify, validate, and deploy. However, even in big data situations with significant redundancy, there are data issues such as outliers, errors, and mismatches. On top of this, there are also human elements such as cognitive biases and information overload. In this presentation, through numerous examples, Professor Gautam will illustrate situations where things can go awry. Then he will also present an approach to go from data to decision. The first step in that approach is awareness. For example, are we aware the assumptions we are making, the limitations of our models, how the data were collected, what are our biases, etc. The second step is understand and manage the uncertainty there. We'll explore many ways of doing it, such as creating scenarios, predicting with intervals, and detailed testing. It would greatly help in figuring out where the errors are before jumping to make decisions, which we often do too quickly. Of course, the last step is decision making, for which we need to determine the objective, multiple approaches, success metrics, and rollout plans, which also includes evaluation and course correction. The speaker will wrap up the presentation with some thoughts on communicating the recommended data-driven decisions. Now it is my pleasure to formally introduce the speaker, Professor Gautam. Dr. Gautam is a professor in the Department of Electrical Engineering and Computer Science at Syracuse University since January 2022. Prior to that, he was the faculty member in the Industrial and System Engineering Department of Texas A&M for over 16 years and in the Industrial and Manufacturing Engineering Department of Penn University for 8 years. In addition, Professor Gautam has been an Amazon scholar since fall 2019. Dr. Gautam's research focuses on analytics, optimization, and control of stochastic systems with applications in computer communication networks, renewable energy systems, real-time logistics, and smart manufacturing. Both government and industry have funded his research projects. Gautam teaches courses in the data science and operations research area and will be teaching 2 classes next semester in Introduction to Machine Learning and Linear Algebra for Data Analytics. Gautam is teaching an online NPTEL course, Decision Making Under Uncertainty, and is also given webinar for NPTEL. All of you know that NPTEL is the largest online initiative promoted by IITs and Indian Institute of Science. Dr. Gautam has received numerous teaching awards. He is a fellow of the Institute of Industrial and System Engineers. He is a department editor for IISc Transactions and was an associate editor for the Informs Journal of Computing. He has served as the chief editor of IISc's Industrial Engineering Body of Knowledge and also was the president of the Computer and Information Systems Division of IISc. Further, Dr. Gautam has written a book, Analysis of Queues, and authored several publications in IEEE, ACM, Informs, and IISc journals. With this brief welcome note, outline of the presentation, and introduction to the speaker, let me hand over the floor to Professor Gautam to enlighten us on the process of making decisions using data. Over to Professor Gautam, please.
Thank you very much, Mohan sir. I appreciate your kind words of introduction. Just bear with me while I get my screen going. Okay. Okay, I presume you're able to see the screen. So let me get started. The picture on your right actually is at Syracuse University, where I'm sitting right now. I believe it's taken from a drone because I really have not seen this exact setting from anywhere. So I'm sure there's a drone that has taken this photo. Anyway, the talk today is about data to decisions and looking at various things that you need to look at to go from taking data and making good decisions. Now, I do want to first thank everybody for coming here. I absolutely understand that we had holidays. I think day before yesterday for Raksha Bandhan. Monday is a holiday for the Independence Day, which is a very special one, 75 years, and so on. In the middle of all that, you all decided to come. I greatly appreciate that you've taken the time to come to this in the middle of this holiday season. Thank you very much. I want to flash this slide here, although I know Mr. Mohan had gone over a lot of these details, but let the slide be there. But I want to say a couple of things. One is, I do want to say that I got a list of people who had signed up for this talk, and they also asked some excellent questions. So some of these slides are kind of adjusted based on the questions. But the more important thing is there I found a category of people attending this talk. So it looks like there were three categories. One category of people are called professionals. The other category of people are called students, which I understand. Sure, students are people who will be professionals very soon. The third category that surprised me a little bit, not that there is not that that is a surprise in itself, but there is a third category called faculty, I believe. I know faculty. These guys are not professionals, huh? Maybe so, because if you think about it, the word professional, maybe people say, "Oh, he's a pro." What's the opposite of pro? The opposite of pro is con. Maybe he's a con man, huh? These professors. Anyway, so I do want to say that my life has not been fully a con man, but I did take a job in the real world by being an Amazon employee, and I've done that for the last more than 3 years. It has been a wonderful experience. A lot of what I would say here is based on both my experience as a faculty member as well as being somebody who worked in the industry. I do have to say that, yes, I've had some experience outside the US, although I've been here for nearly 30 years. And I've taught courses like for NPTEL, as well as in countries like Singapore and Qatar. So that just tells you that I know a little bit about other things. But you know what? I really like to give talks in India, mainly because of two reasons. One reason is I get to talk about the culture, okay, which obviously is food for sure. So Indian food we can talk about. The other thing I like to talk about is cricket. So I will surely talk about Indian food and cricket in this talk, okay, which I never get to do sitting in the US. And the other thing I like is, I think folks in India are so wonderful to speak. I can relate to what they're saying. So this is awesome. So thank you for the opportunity. Okay. So to set the stage in terms of what I do and what my work is about, I do want to put this slide up there. I'm not going to talk about both these items. You can read your screen and figure this out. But essentially, I come from an operations research standpoint, which essentially is about decision making, and my work is mostly about decision making under uncertainty. In the past, I have used what's called probabilistic models, and probabilistic models essentially assumes a certain world and then try to make predictions about how things are going to go. Now, of late, the last few years, I have moved away from that and started to look at data-driven decisions. Data-driven decisions actually start, becoming very interesting, but there are some issues that come up in it. And I do wish to talk about those for the most part today. The domains that I've applied this to, this type of modeling and analysis, has mostly been in computer communication networks, both data center side of things and small things like wireless networks and devices and so on, as well as to very large scale energy systems as well. And more so, well, after being at Amazon, worked a little bit on logistics and also with some of my colleagues in industrial engineering on smart manufacturing. Okay, the word toolkit came a lot during the questions when upon reading. And I do want to say a little bit about this. I normally never have this slide up front, but many people asked about tools. So I thought, okay, so what tools do I use? So my toolkit typically used to be MATLAB. This was back in the day. And I have since moved away, and now almost everything I do is on Python. And I'm still not that professional Python, but the courses that I'm going to be teaching is going to be using Python. It does sound scary because I've only had like 2 or 3 years of experience in it, but we'll see. The other thing I use a lot is a lot of optimization software. Express is one of them, which I tend to use, but there are a bunch of others. My students use a variety of other software. And of course, Excel is always there. And I think my son asked me a question the other day. So what can you do? Why do you need all this other software when you can do a lot of things in Excel? That is true. You can do a lot with Excel. You can draw a lot of nice graphs and charts. You can do a lot of analysis. If needed, you can get VBA and so on. All that is possible. However, there are limitations in Excel. One is that the number of rows you can have is fairly limited, especially in the free version. I don't know about the other version. Okay. Now, in terms of modeling languages, not programming languages, in terms of modeling, I mostly use stochastic-based analysis using Markov chains and so on. For optimization, I usually model it as an optimization problem using a mixed integer program. Then when I use machine learning, I use techniques, various techniques. And you do want to see that, I'm not doing any terribly deep stuff, no deep learning or anything like that. I do know what it is, but I'm mostly using text data. I'm not using voice or I'm not using video data. So, my analysis tends to be mostly text driven, which various techniques like regression and tree-based methods and so on work really well. I also use some simulation from time to time. I just want to give this to you so that what my background and expertise is in. Having said that, now let's move on to our talk. Our talk is about going from data to decisions, and we'll talk about a little bit about creating data, consuming data, and then interpreting and using information. Okay, there were questions about data and information, what is the difference, and so on. I'm going to, at this point of time, keep it fairly fluid. I'm going to almost use it interchangeably, although officially there is a difference. Okay, sometimes the information that you create from data may not be particularly accurate either. So it's not like information is a great thing, data is not. That's not what I'm saying at all. So I do want to say now the last line here, which is highlighted at the bottom. Says the following: whatever I say, and especially because this is going to be online, it's on YouTube and everything else, whatever I say here is my opinion and does not have anything to do with any of my employers in the past or currently. Okay, let's start with a quick comment from one of my favorite people here, which is Dilbert. And yes, I do look more like the pointy-haired boss with balding and a little bit of hair on the sides. Okay. So I'm going to mostly, assume that most folks here are coming from the engineering side of things, and we certainly do give weird compliments. All right, so let me go on. So we all make informed decisions, whether it's in our personal life or at work. So let me start with, those of you that are students or even folks that are not students. You may want to upgrade at this point of time, looking at buying a personal vehicle. Okay, whether you want to buy a bike or a car, the first you have many decisions to make. Now, the first question in that is, when do you buy a personal vehicle? Right? I mean, right now, maybe many of us are working from home. Do I really need a personal vehicle? I can always, if I need to go somewhere, I can always call one of those Ola, Uber, something like that, or whatever else you have. Should I really buy? And if I need to buy, when is a good time to buy? The other question is, what vehicle to buy? Whether should I buy a car or a bike? And then if I decide a car, which car to buy among all the items, or which bike to buy among all the bikes that are available? And from home, that means which particular dealership do I get first hand, do I get second hand? There are a lot of decisions to be made, and how do we make these decisions? This day and age, I'd like to believe that we all go read up online, various different things, look at our bank balances, see how things look like, make a guess about how our life is going to be in the next year or two, and come up with a decision. Okay, maybe I should do this. Maybe I should wait for 2023, see how things look like, and maybe I should buy a car and from the dealership who's next door, and so on. Okay, so you might make such an informed decision. Okay. Now, from a work standpoint, or those of you that have worked with several different companies are definitely appreciating this. But there is this issue. I'm going to my second bullet. We're talking about department stores to soup kitchens. Now, soup kitchen essentially I probably should have used a better word here. In the U.S., there are a lot of these places called soup kitchens where, if for people who cannot afford to go to the store and buy stuff, they can go to a soup kitchen for a much lower price, or even free many times. You get items to take with you. The question is, what do you display on your shelves, and where to display them? Right. So what do you put right in the front? What do you put behind? What do you keep near what? So you have to make these kinds of decisions. Usually, you have some reason for doing that. There was a project that we did with some students a while ago for a soup kitchen, and that's why I remember this, which is that, we're saying, okay, what are some of the popular items? Do we keep the popular item in the front or in the back? There are reasons for keeping them in the front, which is, most people are going to quickly go and pick those up. There's a reason for keeping them in the back because things that are moving fast, if you put them in the back, then people will get to see all the items and maybe they might buy one or two other things along the way. So you have this decision to make, which is, where to keep what item. And you make the decision based on whatever historical data you have from your organization. And we move on to the third bullet. The third bullet says, how much electric power to commit? So this is a lot of utility companies. I'm not fully sure if they've done this in India, but in the US for sure, you have to decide next day, let's say right now it is 7 p.m. How much power are you going to buy from 7 o'clock to 8 o'clock? Okay, 8 o'clock to 9 o'clock. You have to make a day ahead. You have to make a decision about how much power to commit. You definitely have historic data. You know a little bit about what is coming. Maybe you have a function that is coming up. People are going to wake up early in the morning and turn all their lights on. So you have to think about those things. You have to think about what is coming along the next day. What could be the demand like? Maybe it's a holiday. Maybe people are going to stay home and watch TV or something like that. And thereby the electricity is going to be more towards the household as opposed to companies and so on. Things like that. You have to make the decisions based on what kind of data you have. And my last line, which I will go on in the next slide as well, is to, if you're an airline company, you're asking the question, what should I quote as a fare? Okay, what should be the price of of the ticket that people are going to pay to go on an airplane? And this decision actually could be very varying though. Back in the day, we used to have a fixed price, whether you buy the ticket today or whether you bought the ticket 100 days ago, it was the same fare. Not anymore. Okay, now the airline prices could change very frequently, day to day, hour to hour, minute to minute if it wants to. So if you think about this, these decisions are at different timelines. Okay, one decision, the first one on the top, is a one-time decision. I make this one time, not a one time, but once in a while. You don't buy a vehicle every year, maybe once in 10 years. Okay, and so this is a decision that is what I call as a one-time decision for the most part. Then you start making some things that are a little bit more tactical. You kind of make this, you can change things around a little bit and so on. And then there are these, airline tickets at decision where, every customer that comes in, you can decide what fares to show that customer. Okay, so this is kind of like, you want to make a decision and you make a lot of these decisions. So there are implications in terms of how you would model something like that. We won't get into it. Okay, something from the current news. So there's this new airline company called Akasa Air. Was launched recently, and less than a week ago, the first plane flew on 7th August 2022. All my information is from the wiki page. I have not, I know one person who was involved in this company, but that's about it. I have no idea who does this and what's going on. But they made a lot of decisions. Okay, and in fact, one of the questions was, a lot of people who are looking at data are not thinking so much about decisions. And I do want to say these guys have made a lot of decisions. Have they made data-driven decisions? I hope so. I'm pretty sure they did. Okay, so it's not like they sat down and then somebody, the person who owns the company is a billionaire, and he's sitting there and saying, okay, what shall we do next? By the way, I have never started up a company, so I don't know anything about startup, but I pretend like as though I know. So think about this. They're sitting there saying, okay, what shall we do next? And then they think, let's get some big thinking. Big, what do you think? Then say, okay, think of pie in the sky. Pie in the sky, that means, maybe we should look at an airline company. Funny thing is, they said pie in the sky, airline companies and all that, and there is no food on this plane. So no pie. If you're thinking from a Tamil standpoint, no pie also. They're not allowing any bags either. So I don't know. Nonetheless, so they started this company, and then they currently have 2 airplanes, and by the end of this year, they're going to have 18. And in about 5 years, they're planning to have about 72 airplanes. So the question is, how do they decide this number? Where is the 72 coming from? And they're going to add 12 each year. And there are 2 types of planes. How did they make that decision? 189 passengers is one, 197 is the other. There are 2 types of planes. So currently, they are operating between Mumbai and Ahmedabad. So that's the only place it goes right now. I think yesterday they should have launched, sorry, the slides were made earlier, but yesterday they should have launched flights going into Bengaluru as well as to Kochi, and in a little over a month to Chennai. And if you're wondering how did they pick these cities, the conspiracy theory here says, wait a second, they're trying to go to these cities where the name has either changed recently or is going to change in the near future. Maybe we will go hit those cities. This is not how these decisions are made, but sounds like it is. Okay, so it turns out that they would typically look at, what are currently, what airlines are currently serving there. Is there a huge need? Are these flights going full? You can get all kinds of such information, then make a decision. Okay, these are probably good places to hit. But for sure, they would have looked at great data to make a decision how to go about, picking cities that they need to open. Now, they also need to make other decisions that are more than this one-time decisions, like we talked about earlier. They have to look at flight schedules, which is not there on their webpage, and they have, when should a plane go? See, they only have limited planes, 72, but what typically happens, the plane goes from A to B, from B it goes to C, from C it goes to D, and so on, and that schedule needs to be nicely decided and managed, okay? So that is also, it's not a one-time decision. You can make changes to the schedule, but usually, this is more like a tactical decision. And real-time decisions are like ticket prices. What should you quote for various passengers and so on? So there are two issues I talk about. The first issue here, the last bullet there. I don't know if you can see my cursor. The last bullet there is the frequency of decisions. So sometimes you make decisions often at real time, every nanosecond, microsecond, especially if you're working in the stock exchange. You have to make decisions in nanosecond granularity. Okay, and see something, boom, you have to do that. And also, there's opportunities to course correct. And this is a very important thing. So when you're making decisions with a lot of uncertainty, you make a decision, but you can course correct. Okay, that means you can change things around. Like, for example, if they're not able to open in Chennai on September 15th, they're saying, wait a second, maybe we should not do this. Maybe we should not get 72 airplanes. Maybe we need 100, okay, or maybe we need only 50. Now, you can change these numbers, and that's why they kind of make commitments over a longer horizon so that they have the opportunity to course correct. That means make edits, okay? All right. So what is the process of making decisions? And typically what happens is you gather relevant data. So that means, go, like you want to make a decision about these airplanes, you go and find out, what is the need of customers. And then, you make some suitable assumptions. About modeling, because modeling is all about assumptions, and I'll talk about assumptions a little later today. Then you want to analyze your data, then you can build some models, make some predictions. Then you go to do a whole bunch of testing. Okay, that's very important, and then you deploy. Now, let me give you another example. The example is below here, with this picture of a dosa. So let us say, how do you gather relevant data? So let's say you're sitting here thinking, okay, let me go and talk to a bunch of people. I like dosa, maybe people like dosas as well. Let me call a bunch of folks to ask them, what are some of the issues you have? So one of the issues is, if you want to make rava dosa, it's very hard to make it, at home. But you'd like a nice crispy one, not so soggy. What do you do? Okay, so then these are the issues, right? These are the customer issues, which is, I'm not able to get the dosa which is nice and crisp, hot. How do I take care of the problem? But I don't want to go to a restaurant. I don't want to drive up to a restaurant or go in traffic. I don't want that either. Then wait a second. Maybe what we can do is, maybe we could have a home delivery type of dosa truck, where this vehicle comes home, makes your dosa, and gives it to you right there. So the making happens right outside your apartment or flat. Okay. That might take care of all the issues. You don't have to go to the restaurant. You don't have to, you can also get a crispy dosa if you'd like to. Well, that sounds great. Again, like I told you, I have never started up a company, but that sounds like a startup idea. So what do? You go gather relevant data. Are there people who would be interested in something like this? Is there enough of a population? How long does it take for me to go from point A to point B? Can I actually even make money with this? Is this even or is this a money down the drain? Because by the time I go to 5 places, it's going to take me an hour. You have to gather this relevant data to make a decision. Should I go about something like this? Okay, then you have to make suitable assumptions. The assumptions here are very crucial. Now, a lot of times, initially, there's a lot of excitement. Okay, everybody jumps in, and you'll do a pilot study, and people would love it. Okay, and then what happens is after a while, things get old, and it may not be the most ideal thing. So you have to make some assumptions about how things are going to go into the future. Then you analyze your data. You have to really comb through the data, look for a lot of things, do a lot of interviews and so on, and analyze the data. Then you build some models. Okay, and in this particular decision, the model that you would build is essentially going to ask you what is going to be the the distribution of the profits that I might possibly see. It may not really want the average profit, but kind of like some type of a distribution. Okay, and then you want to make a prediction. Okay, so if I do this, what's going to happen? Then you do a little maybe first do a simulation of it, and then you look at it, validate it, and maybe do a pilot study and so on. And once you like it, you go ahead and you deploy. So this is usually the process. Okay, so everything looks hunky-dory, but there are issues. Okay, so when you make these data-driven decisions, there are usually some type of issues. Now, I do want to say one thing really quick, is towards the end of the talk, we'll get an opportunity to ask questions. Right now, I'm just looking straight at my screen, and I'm not able to see all the questions that are coming up. So please leave your questions towards the end. But there are issues to these things, right? So what are the issues? The first issue is data-related issues itself. There are always outliers in your data. This, when I did my usual stochastic models where I was not using real data, outliers were never there because your data behaved exactly what you wanted it to do. Now, not your data, I'm sorry, the distributions were exact. All of a sudden here there's an outlier. Now, for example, I'm from North Carolina. That's where I did my PhD, and one of the most famous North Carolinian is a fellow by the name of Michael Jordan, who's one of the greatest basketball players ever. He was graduated from the geography department, and if you look at the salaries for the geography department people, or the amount of money they made, you will find a nice, beautiful-looking distribution. And all of a sudden, Michael Jordan, not only is he very tall, but his salary is phenomenally high. This is an outlier in the data. But if you're going to try to fit a model to this data, it is going to be a mess. Okay, it will not work out as nicely. What do you do with it? The second issue, more common, is what is called missing data. And those of you that have used Python know what I mean here when I say fill now. Fill, that means when you have a thing that is missing, when you have missing data, what do you fill this NA with? Okay, when the data is not available, what do you fill it with? Do you fill it with averages? Do you fill it with median? Do you fill it with worst case, best case? There is no science to this, and that's scary. Okay, and so the question is, and so you shouldn't say there's no science. So the science there is not going to tell you this is the best thing to do. Okay, so let me put it that way. Now, the other thing is there's always errors in your data. Okay, and some of my great friends who are excellent data engineers can kind of smell errors in data so beautifully. Okay, and they can also tell you, if there are mismatches and so on. However, it takes a lot of experience to know, when the data has errors and when there are mismatches, and of course, missing data you'll always know. But you need to know what to do about it. Then there's the other issue. I will touch upon these as well. It is the human element. Okay, and this is also extraordinarily important in this day of heavy WhatsApp usage. We are biased. We get biased. We act like we don't have any biases, but they are there. There's also the issue of information overload. In fact, my slide my talk itself might be an information overload in the first place, where I just throw in a whole bunch of information, but there are these things to think about. Now, we like to think when you have a lot of data, these problems are not there. That is not true. When we have big data, the problem is these problems are still there, and you don't see them often. And when you are presenting it to senior leadership, they will spot it saying, wait a second, how did this happen? This is very common, and we have to be very careful. Even though there's a lot of redundancies, things don't really match. Okay, things don't really match up. For example, if you add up all these numbers, it should be equal to this other number, but typically it will not be. Sometimes simple things like round off errors could cause that problem, but other times there's something really complicated, and we have to be careful. Okay, so I want to talk about three particular anecdotes, and before going ahead. The first one, which is one of my favorite, I always like to say, sampling data is very important. Okay, so the first one is, let's say you're thinking about a situation where people have been complaining that this particular traffic intersection, where there's a red light, there's red, yellow, and green light, right? So the traffic intersection is having a lot of problems. People are really upset by the way it is, amount of congestion there is, and so they call a traffic engineer and say, hey, can you do something about it? The traffic engineer says, okay, let me put a little sensor. And when the vehicles are moving, it is really difficult to actually count how many vehicles are there. So what I'm going to do is, as soon as the light turns red, maybe I will wait for 2 seconds, and then I'll take a photo, and then see how many, and then have this algorithm that will count how many vehicles there are. So think about this. Is that a good idea? Right? No, because the moment you go from green to red, chances of that line being really long is very low, right? Because people have been going so far, you didn't give enough time for the line to build up. So it's a terribly bad idea to have actually taken the data there. But we often don't think about these things. We often don't think, here is a good time to take the data. You want to really get excellent samples. Talking about samples, the second example is about a soap dispenser. This is a very famous study. So when a soap dispenser, we all know what this is, right? Thanks to COVID, some good things came out of it, which is everybody uses a soap dispenser these days. The soap dispenser, you put a hand in there, the soap gets on your hand, and then you clean out, right? But in this case, a soap dispenser, you could have also had, instead, you could have had this hand sanitizer come out, okay? What happened when they started the soap dispenser? It turns out that people with darker skin, this thing was not dispensing any soap. It was dispensing perfectly fine for people who are fair skinned. Okay. Oh, this is a big problem, right? Could this have been avoided? Sure, if you had done your testing properly. And remember, we were talking about this testing. This could have been avoided. You would have seen that there is an issue here, and you can read up as to what the exact issue was. You could go online and read up about it. The last one, this is a very common machine learning error that a lot of people make, which is the following. I collect historical data. Okay, so let's say I'm using random forest. Okay, this is the example that I'm talking about. Let's say I'm using random forest as a regressor, and I would like to predict what things are going to look like. Then I use some inputs based on historical data. When I have historical data and I train the data, I use training data, and I train the model and the data. And then you test. And while testing, you see that the test data is outside the range of the training data. Okay. And this is very common in the industry, right? You are always kind of growing. You have historical data, which is something that you have for models. But your future, you're looking at a growth pattern, and none of these data points that you are anticipating in the future ever happened in the past, and you're trying to guess how life is going to look like in the future, and you use a random forest regressor. These results are going to be highly inaccurate because these models necessarily use based on your extrapolation is really a bad thing when you use a random forest regressor. So it's important to understand what is behind some of these models and how things work out. Okay, I'm looking at my time. Okay, I'm at about 45, right? Okay. All right, so I'm going to talk about the approach to go from data to decisions. The first step is, there are a lot of things we need to be aware of. We need to be aware of the assumptions being made, the limitations of the model, how the data was collected, and our biases. I'm going to talk a little bit more about these four. Then I'll quickly talk about how do you quantify uncertainty, right? Especially you need to understand what is the uncertainty in the data that you originally used, and in the system itself might have some uncertainty, right? In the airline company situation, you might have maintenance issues that you were not thinking about all of a sudden, and you've made all these fancy schedules assuming that flights are always going to be available, and then there's a mechanical failure, everything goes up. Okay, so you want to think about. You also want to think about the future, right? The future is uncertain, which we all know, and you want to make sure that you appropriately incorporated models for that. And finally, as the last step, you make decisions. You have to decide what is it that you're trying to optimize, for example. And if you're in an industry, more often than not, you're trying to optimize how much money you're expecting to make. But for one-time decisions, is that the right objective? That is a very important question to ask. And we're going to think about what are the approaches you're going to use to solve this problem, and what metrics you're going to use to solve these problems. Okay, well, and these are important questions. So I'm going to quickly talk about the issue of biases. I know that it's important for us to talk about it, but what it is, I don't know if you can see the slide clearly as soon as it comes. So this is another Dilbert cartoon. Like I said, the pointy head guy has to be there in all my slides so that yes. So yeah. So essentially, this late. I don't know if you can read as well, but essentially, what is happening here is, it says, as long as the model gives me the answer I want, what is the problem? Okay. So this is an attitude that a lot of people have. Okay, and we have to be very careful. Now, there is a statistical type of bias. Okay, and this one many of you may have seen. There's a formula for mean and for standard deviation. And the mean has an n in the denominator, standard deviation has n minus 1, or the variance has n minus 1 in it, and we take the square root. Why is there an n minus 1? That is the statistical bias that we're trying to avoid. I won't go over the details in this talk. There's the issue of correlation versus causation. You can see the stick figure. It's a beautiful explanation about that. Many times we don't understand the difference between correlation and causation. Many times we just say, well, A is correlated with B. That does not mean because of A, B happened. It's like this. This happens a lot though, especially when we watch cricket and we're saying, oh, if I wear a blue shirt today, India will win. But then do you really believe that India is winning because you wore a blue shirt? Because when maybe every time you wore a blue shirt, India won. That is correlation, okay? But it is not a causation. You're wearing blue shirt did not make it to win. So that's an important distinction to make. I'm going to talk about sampling bias in the next slide. Sampling bias. Now, I'm not sure I want to go into so much detail. I'm looking at my clock. Maybe I should quickly run through this. So if you think about it, how are you going? You're going to take a sample and you're going to extrapolate this to the world, and this is called sampling bias, right? So let us say you're in a hospital and coronavirus, cases were there, and 1 in 10 people did not survive. So can you say the death rate in the whole India is 10% or whole world is 10%? Can you make such claims? The second question is, let us say out of 1,000 people tested, 200 were tested positive, and let us even assume the test is perfect. This is what I'm talking about, assumptions. Making some assumptions. Just say test is perfect. Can you say that 1 in 5 people get the virus? Can you say that? Well, it depends on who you really tested, right? Did you test only the people who came to the clinic saying, oh, I have a fever and seem to have a cold, and you do a test and 1 in 5 didn't have? Then surely, your sample is highly biased. The other thing is, well, what if people, maybe you didn't do that, and maybe you did something slightly better. You put an ad in the news media, and then the ad went out, and people who heard the ad immediately came running to get themselves tested because free testing is available. But let's think about it. Who would have seen the ad? Not the people who are working, but people who are sitting at home and who are possibly working from home, but who are in isolation. So maybe the numbers are probably skewed because of who got tested. And lastly, maybe they're offering an incentive like $5 for doing a testing. who will show up? I mean, people who really need the $5, right? I mean, everybody's not going to take the trouble to go show up for testing. So your sampling might be biased. You need to think about that. And many times we don't get a chance to think greatly about this. Okay, I'm going to just say that because running out of time, I want to go to the. I also want to talk about this very briefly. I know that you all will, especially those of you that are logged in on the Google Meet, will get these slides. I do want to say that many times we have to rush through some of these slides, but as it turns out, in fact, even on my other screen, my slide is not moving actually. So I've already gone to the next slide. So let me just take a second to just go back to the previous slide and then go to the next slide. Okay, so let me just talk about this very briefly. So there is this issue of what is called confirmation bias, and this is the worst of all the biases. Okay, this is, we think we don't have confirmation bias, but confirmation bias exactly happens all the time in WhatsApp. Okay, so what you read, you really gels, and then you forward, right? Because you will say, oh, this makes a lot of sense. Okay, because this is your belief that this is actually true, and you think that this is absolutely the truth, and you just forward. When you forward that message, what you have undergone is what's called a confirmation bias. Okay, and typically there are other types of bias, anchoring bias. The first thing you hear, you stick to that. Okay, there's also something called availability bias. Whatever information I have, I use that to make my decisions. There you're falling for what's called availability bias. And then there is this issue of overconfidence bias. Okay, and many times, a lot of people have only had their experiences and they make a decision being overconfident. Yeah, everybody will love this. Who wouldn't love, having dosa coming to their house that is crispy, for example. Okay, so I'm stopping here in my slides to say what is called midway remarks. I know I am way past midway, but nonetheless, I just want to take. Are you all able to still get the slides, or is there a lag? Because on my other screen there seems to be a lag.
Sir, we are able to see, sir.
Okay, you're able to see the slides that say midway remarks?
Yes, sir.
Excellent. Super. Thank you. Because my other screen is not showing that. Okay, perfect. Okay, excellent. So I just want to quickly, and I do know that this is midway, but I will wrap up in a short while. Okay. So we make decisions all the time, whether it's in our personal lives or in professional lives, and these data-driven decisions very recently have become a big deal. Google recently said, how they evaluate their employees and so on using data has of late gotten a lot of traction. And they are definitely perceived to be better than uninformed decisions. People making decisions, like I said, let's think about some big ideas and just throw that out, but actually making decisions based on data. But there are issues, there are errors, you could have biases and all that. I do want to spend a second talking about Simpson's paradox, and this brings me to my favorite sport in the world, which is cricket. So let's say there are two cricket players, A and B. Okay, and you are looking at their strike rates across 3 one-day matches. So we look at their strike rate, and basically your decision is to pick A or B to play your next match. Okay, now strike rate, for those, just in case there's somebody in the audience who doesn't know what that is essentially the number of runs you score divided by the number of balls you face, multiplied by 100 as a percentage. Okay, so essentially it is how many runs, if you were given 100 balls, how many runs you would possibly score. Now, we all know that higher strike rate means the player is a better player. Okay? And that means he can, I shouldn't say better player, at least he's more effective at scoring fast, or she is more effective at scoring fast. So now let's say there's 3 matches that we talked about, one-day matches. A has a strike rate of 125, 90, and 90 in the 3 matches. B has a strike rate of 110, 80, and 80. So clearly, the first match, A has a better strike rate. Second match, A has a better strike rate. Third match, A has a better strike rate. Who will have a higher strike rate overall across the 3 matches? Okay. when those of you that are it's been a while since you went to the university and wondering, what is going on. Obviously, if I ask a question like this, there has to be a catch, right? Yes. So I wouldn't be asking such a trivial question otherwise. So let's dump into the data. This is what I'm talking about. This is information. This is data. Okay. So I shouldn't say this is data. This is information. You're diving a little bit deeper inside. So what happened in match one? In match one, the first guy scored 15 runs from 12 balls, getting a strike rate of 125. Likewise, scored 81 in 90 balls, getting a strike rate of 90, and 117 out of 130 balls, getting 90. So the total strike rate, the total run scored 213 divided by total balls faced, which is 232, strike rate of 91.8. The second guy, on the other hand, had a lower strike rate in each of the matches, but if you look at the red number in the right side, in the series, he has a much higher strike rate. All of a sudden, although in our individual matches, it appeared like A was far better, more than 10 percentage points higher than B. Okay, but overall, B has 7 percentage points higher strike rate than A. This situation is called a Simpson's paradox. I do want to explain what exactly happened there so that, those of us that are wondering, well, what did this guy do? Is he even get his numbers correct? We'll see. So this is the same as this. The situation, let's say there are two people, C and D. C walks faster than D. C runs faster than D. Okay. Yes. C walks faster than D. C runs faster. Yes. So and we're asking the question: what is going to be the total distance, or who will go first if they walked and ran a little bit? Now, if D walked a little but ran a lot, and C walked a lot and ran a little, you can see that clearly C would reach the same distance C would reach at a later time. That is because they did more walking and less running, okay, as opposed to D. Although their walking speed is better and their running speed is better, the amount. Sorry?
We are seeing only the introduction, Simpson's paradox introduction screen, sir.
Oh, okay. So this is slow a little bit, huh? Okay. Thank you for letting me know. Okay. So let me do the following. Let me stop the share. Are you able to see now? Now is good?
Yes, sir.
This is perfect. Sir. Thank you. Thank you so much. Oh, so you didn't see this example, right? Thank you for bringing it up. So let me just show this example that was not seen. Thank you, ma'am. So, right. So essentially what is happening is, let me just repeat what I said. So the strike rate for player 1 is 10 percentage points better than player 2. Okay. But if you take the full series, the player 1 has a worse strike rate than player 2. So, I mean, although A was better by 10 percentage points in each one of the 3 matches, but B has a better strike rate than A. And notice that there are 2 numbers that are random: the run scored and the balls. I'm saying random as in variable. Okay, run scored and the balls faced. Okay, both are varying. So if you look at a similar example, when people are walking and running, and I think I can see in my second slide when it comes. When people are walking and running, what happens is you have a similar situation. The reason is, although one person walks and runs faster than the other person, if they spend more time running than walking, even the slower person can beat the faster person. And that is essentially the story that we're trying to say here. Okay. So here, if you see the person D, although they walk and run slower than person C, the fact that they spent more time running than walking brings them faster. And that is essentially what happened in the previous example. It's not like it's a major paradox or anything like that. It is just that, the way we had looked at numbers. But the point that I'm still trying to make is, if you just look at that information and you decided to go with player A, maybe it was better to pick player B. Again, I'm not saying what you should do, but I'm just saying question your data. So The next thing I want to talk about is assumptions, and I do realize that I'm getting very close to the end time. So I will quickly talk about this, not go into a whole lot of detail. Some of the research that we did recently is, let us say you have a business that is opening a new delivery business, like a Swiggy or a Zomato. You're doing some deliveries. And the question that we want to ask is, what's the probability that a particular driver can make these end deliveries and return? Okay. And we looked at some data from 3 cities, Austin, Boston, and Portland, and saw some nice data and so on. I won't go over a lot of the math here, but essentially we make an assumption that according to central limit theorem, this is normally distributed with a given mean and variance and all that. And we looked at these 3 cities, namely Austin, Boston, and Portland in the US. Okay. Now, we first need to know what assumptions we're making. We're making some assumptions about the distances. Okay. Although we should be thinking about road respecting distances. Oh, maybe my slides are a bit slower. Good. I end up actually using these Euclidean distances because I have latitude and longitude. And I make an assumption that this n is large enough to use this theorem called central limit theorem. And I extrapolate. I look at data for 3 cities and say, okay, this should be true for all the cities. I am making an assumption that every address is equally likely to get a delivery. This is not true. Some people like to order more often with Swiggy than others. And whether this average speed, everybody drives at average speed, is that a reasonable approximation? Then our results are not taking into account weather. This could be an issue. And then we assume that the travel time that is made between various legs are independent. That's another assumption. So just notice a simple analysis like this has made so many assumptions. Lastly, this data was got from this site called Airbnb. I don't know if you're familiar with it, but is that a representative sample of delivery addresses? So there are a lot of assumptions that were made. And the important thing is to ask, are these assumptions valid? Okay. So what happens is in practice, the results could be quite off when you don't understand your assumptions really well. Okay. Many times, again, I'm looking to see if my slides are chugging along. Let's see. Many times it might also be expensive to do what is called course correction. Okay. But the famous statistician who's from Wisconsin, George Box, said one thing. This is very important. A lot of us, that especially the faculty types, are very surprised by this statement by George Box. He says, all models are wrong, but some are useful. Okay, so the fact that they're wrong doesn't mean you don't use the model. Some of them are useful, and we should go about using the model. Okay, are you still able to see the slides? I'll wrap up now.
Sir, we didn't get you.
Are you able to see the slides
Sir,
correctly?
we are able to see the screen assumptions, knowing what they are.
I'm about a few things early. Oh, ahead of that. Okay, that's what I'm thinking. Oh, I don't know why this is happening. But it's almost, time has almost come to the end, right?
So you can take your own time, sir. No issues, sir.
No. People, I know people are eager to have dinner. So, okay. Let me see where we are. So we did this. I don't know why it got stuck here. So let me just escape. When I escape, it does better. Okay, so that's good. So then what I did is, so just look at the last line. It's not crucial to read all the others. The last one. So George Box said all models are wrong, but some are useful. Okay. So then we talk a little bit about predictive analytics. That is, how do you manage uncertainty? So one thing that I like to always say is, so let us say you are having a photovoltaic panel and you want to forecast how much of solar power you're going to get, and you are predicting, y1, y2 up to yn. The actual values of a1 through an. Your competitor has a different value. how good is the prediction? So it is not that there is one good metric. There are so many metrics. So that is one issue. But the more important issue is, the fact that you're predicting single number. Okay, we should always try and predict an interval, not a single point. And another thing is, the other thing is, how do you go about managing this uncertainty? One thing that is commonly done is, creating scenarios. Like, you want to create scenarios of how things will be into the future. And you want to also make sure that when you predict, you don't predict a single point, but you give some intervals. You want to also do what is called detailed testing. You want to do a lot of testing, but you want to make sure that you also analyze everything. Now, I am known to do the last line, which is called analysis paralysis. Do a lot of analysis and go crazy. Anyway, so let me just again. This is good. I'm just going to escape and bring this back. Okay, so usually people use a distribution to quantify uncertainty, and then you build a model, this is another anecdote. I don't know if you have that much time to talk about this. I think developing an intuition for variance and standard deviation is very important. So let us say there are two products, A and B. Let us say the time to make product A is 5 minutes on average, 5 minutes on average for product B. But product A has a standard deviation of 4 minutes. Product B has a much smaller standard deviation of 2 minutes. But notice that the time to make is always a non-negative number. So you should not think of this as normally distributed. It was not going to be normal because, if you look at the mean and standard deviation, they're really close. Okay. So then we're asking the question, which has a lower P50? That means 50th percentile. Now, turns out that product A, more often than not, will take lesser time. It is not most intuitive. You're looking at the standard deviation as a higher standard deviation, probably is a bad idea. No, we've been taught that variability is a bad thing, but turns out that more than half the time this will be, it is better. But there, from time to time, you could have the other direction. But my point here is to say, that when you look at this P50 and so on, you want to be sure that you understand what exactly this is doing. Then I do want to talk about this issue of fitting distribution. Again, another aspect that that with big data gets really crazy. I'm going to just spend one very quick slide to let you know that when you try and fit a distribution, and you typically assume that a lot of the data from the same distribution, when you had a large sample size, every known test that you can think of, goodness of it, will fail. Okay, that is because you have such a large sample, and whatever distribution you pick, it will end up failing. So this is an important thing to think about. Now, I do want to wrap up a very, very last couple of slides to say, then you have to make decisions under uncertainty. If you're interested in learning more about it, there is this course that is going to start at NPTEL on this topic that I have recorded. You're welcome to view that. The main thing is, what criteria do you use for making decisions under uncertainty? You have to be concerned whether it's a one-time decision or a decision that you make repeatedly. And then there are multiple approaches. Once you make the decision, there are multiple approaches. One approach is called stochastic programming. There are other approaches called that use approximate models. There are approaches that one of them is very popular called reinforcement learning. You have a machine that learns and makes decisions, and that is there. And of course, you can use simulation. The question is again, what success metrics do you use? And how do you roll things out? Do you have opportunities to course correct? A lot of times these are issues, especially for the professionals out there. Okay, now a lot of us, are really find it not surprising when somebody says, there are three types of lies: damn lies, and statistics. This is, really gels well because many times people don't really, don't really agree with a lot of things that get presented. People feel that you cherry pick data and so on. So clearly, now there are a lot of trade-offs that we wish to make. In the interest of time, those of you that will get these slides can definitely take it here. But these are some very good books that I highly, highly recommend. Okay, if you get a chance, these are popular media books. try and read. Nate Silver wrote a wonderful book called The Signal and the Noise, where, when some of these predictions don't fail and so on. There are these two books, the last two I highly, highly recommend. A book called How We Decide and Thinking in Bets. In particular, many times when we say, oh, this was a great decision, you say that it's a great decision looking at the outcomes. Okay, that is not the right way to approach. Okay, in the sense, you make a decision for something that is going to happen in the future. Okay, then a good decision is one with that information. What did you decide? Okay, as opposed to once the future has unfolded, you're making a statement about how good or how bad that decision is. Okay, so when this book is a wonderful book that talks about it. So this is my summary slide that says, in summary, you need to be sure that you understand your assumptions. You make sure that you know what the limitations of your model is. You make sure that you know how your data was collected, what are the biases. Then you make sure that you understand and manage and quantify this uncertainty. That is very important to do, both in the data as well as in the future. And finally, there are approaches to make decisions, and I didn't go over them in great detail. However, if you use data to make decisions, you have to really question some of this data. Now, I want to talk about some other takeaways and thoughts for the three types of people, like we said in the beginning, for professionals, faculty, and students. This is my absolute last slide. So firstly, if you're a professional working in the industry or for the government, you're wondering, I need to develop this ability to pick if something went wrong. Some of the greatest leaders in various organizations have this ability to spot things that are not right. Okay. The other thing, oftentimes, and especially many times when I talk to people, they know how to use a tool, but they don't know how the tool works. And I think just because it is difficult or uses a lot of science or math or whatever it is, doesn't mean that you should not know how it works. So you should. It's always important to understand how the tool works, okay, or what are the assumptions that go behind it, and so on. A black box is not the greatest of things. Now, this is a very important thing. Please share your data with faculty and students, the other two groups in this, because it is a win-win-win for all three groups, right? Because as a professional, you can get some problems solved quite nicely at the universities with students. Secondly, you get students who are already come trained with your data. They know how to analyze it. So that is a wonderful thing. And finally, it is good for the students as well, right? If you think about it, they get to work on real problems and then we are able to solve it. And for faculty, this is a great thing. They get to teach material to the students that they might end up using when they go and get a job, right? So it's a win-win for everybody. Now, the other thing is, many companies, you are never clear about how certain decisions were made. So when somebody leaves the company, another person gets promoted, they're wondering, how did this guy make this decision? So it's important for you to be transparent in the companies about how decisions were made. Now I want to talk about faculty. Okay, it is important that when you work with your students, to go over the assumption. Like I was telling you, it is important that students know what are the assumptions being made while working on this problem. And then the other thing that I would highly, highly recommend is to collaborate with people, with colleagues and companies by building relationships and working on some problems together. And there are these fora, right, like IEEE and ACM and other places where you get to meet people who are professionals. Unfortunately, my talk is online, but on a webinar. But in a physical meeting, go to these meetings and make sure that you can promote your ideas. And one warning or takeaway is, many times we use these fancy models. Looks like I'm again slowing down in my. Okay, so it looks like many times when we use these fancy models, these models don't fit the real data, and this is to be concerned about. From a student standpoint, remember that data is very messy. We, as faculty, don't teach you how to clean up data. How do you fill those numbers? We don't really teach you that. Data is always messy. So remember that. Companies, now this is another thing that's very interesting. Companies always want descriptive and predictive analytics. They don't really want prescriptive. Nobody wants to tell them what they should be doing, what decisions they need to be making. Although this decision part looks all nice, fun, and hunky dory, many times these are taken by at a different level. You will be asked to make predictions, but you always ask them, why do you need this? Why do you need to make these predictions? Okay, and I think that is very, very important, because many times I've heard more often than not saying, oh, this group of people gave me this data, and I use this data to make this decision. Now this data itself is wrong. Okay, so you want to ask, what are you going to use this data for? And definitely learn the science behind the tools. Okay, very often I've seen people come and say, I don't know what this is, but this is my data. Don't get into a habit of understanding the science behind the tools that you use. There are a bunch of these interesting NPTEL courses. If you have to take something online, you can always do that. And finally, try to get a summer internship, at some company, even if you eventually want to get an academic job, which I saw a lot of these students are, PhD students and so on. Even if that is the case, even if you want an academic job, it's good to get a summer internship. Okay. So having said that, I am done with my presentation and I'm open to taking questions.
So good evening, sir. Thank you very much for your wonderful presentation.
Thank you.
We have received a few questions from the registered participants. I will read out one by one, and you please give your answer, sir.
Yes,
So
thank you.
Read from the questions which we received in the chat box now. Could you share some real-life business examples of data-informed decisions going awry?
Okay. So I had assumed that I did that when I gave. So if you look at this, I don't know how my slides went, but let me take you. So if these decisions that I talked about, these are actually real decisions where things really went wrong. Okay, actually there were people who did this camera situation. Actually, there were people who did this. This soap dispenser is a very well-known problem, because this one, a lot of people, get very, very excited about this problem. So, but these are all. But almost all the examples that I gave is because of this. Okay, so for example, a lot of times in Amazon, this thing I will tell you is there's a lot of missing data. Okay, and then we make some type of decision, and then and based on this missing data, it turns out that they are not really what we were thinking they were. I'm not able to tell a whole bunch of additional exact details, but when they go wrong, they can go really, really wrong. But most of these examples that we talked about now, for example, this one, these guys have made this decision. Who knows how this would go, right? And so that is kind of what I was trying to say. But let me see if there are other questions that I could during the presentation. If there are other examples that are more interesting, I will bring them up. Can you go to the next question, sir?
Yes, sir. So please let us know some good book for undergraduate students.
Okay. So this is interesting that I should. Let me plug for a new book that is coming up very soon, and then I'll give you another book. So Dr. Balu, who some of you may know, I know Mr. H.R. Mohan knows him very well. So Balu sir is going to come up with this book called From Decision Science to Data Science. It's a wonderful book that as a small thin book that's going to come out very soon, and he talks about how you go from data to decision. So that's very nice. However, what I will do is I will create a few good books. So I think there are books. I think Professor Srinivasan has written this book called Quantitative Models. I really think it's a wonderful book for undergraduate students to read. So Professor Srinivasan's book, this book also is a very nice book. Okay, this the lucky things that I'm presenting from my office. I give you another office book which is very nice. This is one book. Yeah, there are a few books, but let me do one thing. I can probably reply by email with probably a list of 2 or 3 good books, if that's okay.
Okay, sir. The next question is how to identify the suitable training models.
Oh, okay. Okay. How to identify suitable training models? Okay, so is I think that in and itself, let me say 2 or 3 different things. So many times, what we tend to do is we are in a time-bound crunch, and we just do our best to submit. And I think the first thing that you need to do is ask for plenty of time. And many times, what happens is the data we collect in a great hurry, and have deadlines. So secondly, discuss with a lot of people, have a brainstorming session, and try to include as many people from various backgrounds, different, both there has to be men and women in the group, people who are older, people who are younger. Have a nice group of people, everybody look at, how you're planning to collect data. And then, try to get inputs. Generally, involving a lot of people who are doing this. I do understand the downside to everybody will have their own opinion about what is good and what is not good. But if you go about running things by a lot of people, generally that is very useful. We may not always think about all the things that are important, and somebody or the other will. I will also take that step one this thing further. Now, for example, I have a son who is 16 years old, and many times, I'll just run some things by him, and who does not work on this topic. I mean, he does not work in the first place, but he does not work on this topic, and he might completely think of some out of the box ideas. So it is more tricky at the university level. I mean, sorry, at the company level, much easier at the university level. Try to also not just talk to people in your company who are diverse, but try to also in your audiences, try to look for fairly diverse type of audience so that you get perspectives that are more reasonable. I think there are a lot of questions. I will stop here. Go ahead for the next question, sir.
Thank you, sir. Next question is, it is always correct to take a decision on data because data is always showing the quantitative aspect of such a decision. What about the qualitative aspect of such a decision?
So that's a very, very good, very, very good point. So there are a lot of qualitative aspects of decision, and that is why I said many times when you make especially a single decision, it is not necessary that when you make a single decision or a one-time decision, a quantitative thing is generally the best thing, because there will be so many parameters. For example, when you make a one-time decision, you can come up with when I say something like, okay, let's say somebody wants to get married. That's one of the biggest decisions we all make in our lifetime, right? To who to get married to, and for the most part, it's a one-time decision. Okay, then what happens there is, there is something one doesn't typically go very quantitatively to make the decision, and you don't have much data either. This day and age, you can go look up the person a little bit, but what factors, right? What factors matter? And I agree with you. There are many other factors. If you can quantify those factors, that's great. Many times you don't. So the way to quantify multiple factors is to do what is this thing called a Pareto frontier. Okay, so that means you have multiple factors, each of them having a different axis, and you want to see possibly how to go about making this decision about, okay, maybe I will categorize prioritize my factors a little bit. But there are also a lot of these, gut feeling type of decisions, which are what people usually call qualitative. I am not in the business of quantifying them, but they are extraordinarily important. A lot of times people say, when you make these kind of qualitative, that book that I told you about, which is I'm going to go up in this slide and show you. This book talks a lot about those types of, people who make this from the gut type of decisions as well. And it's a wonderful read. Next question, sir.
Thank you, sir. Next question is, what is the difference between data science and decision science in terms of tasks performed in an industry job?
So let me answer this very quickly, but my point here is, like I said, so for data science is what we call as could be called a descriptive analytics or predictive analytics. Descriptive means you're trying to say things like what is the average performance, or what is you're coming up with getting the data and describing the data. It's called descriptive statistics. But predictive means you're trying to predict what will happen in the future. But a decision, so for example, to give you a simpler example, so even in companies, right? So let us say the Swiggy example, the what you're saying descriptive is, so for example, you might think like, okay, what were the kind of food, what are the kind of restaurants historically have people been ordering from? What were the kind of foods people are ordering? You can get all kinds of data. And producing that result is called a descriptive statistic. Predictive means, trying to say, okay, tomorrow I want to decide, maybe I want to speed up, or maybe next year I want to speed up my deliveries. So maybe what I could do is I could start stationing these people in different locations so that, they're nearer the stores and they could go and then pick stuff up a little bit faster. So you're trying, you want to make the decision. You want to make a decision about where to put the people, but you want to make a prediction about what is going to be the demand. So that is the data science, okay, which is to say what is going to be, what do I predict as a demand and so on. Then my decision is I'm optimizing that. Okay, that is a decision science. But I'm taking that information, putting it into a model, an optimization model. Things go ahead typically, but many times the problem is that we tend to tend to separate these two things out. People will say, give me the predictions, and they will use the predictions to make a decision. Research has shown that this is not the most effective. They have to kind of go hand in hand. Let's go to the next question, sir.
Next question, sir. What is the difference between information and data in decision making?
So I think I'm going to let you read up on the lot of articles online. So typically, data is just raw data that you got collected, and information is cleaned up data that is well presented to make decisions. Okay, so raw data can have all the errors and all the outliers and missing and so on, and what information you collect from the data now. But there are other people who look at it differently. Now, for example, if you look at, let's say, this photo that's on the screen, if you look at the pixels, there'll be just numbers like 0, 1, and so on, and pixelated information. That is data. Information is to take that data and put and run it through a software that will put a picture around it. That is information. Depends on who you ask. For different people, these things mean different. From my standpoint, I mainly look at data that is tabular, and therefore for me there's not a massive difference. Analyze data sometimes I call as information, but I don't want to go too much into that, especially this talk didn't have a whole lot of that aspect.
So last question.
Yes,
what
sir.
are the preventive measures that could be taken to safeguard one's data?
Yeah, I think this is a big question. I would recommend. I'm definitely not an expert in security. However, generally, I think what I'm going to say is what a lot of people have generally said, which is, don't click on stuff that you shouldn't be clicking and so on. But more than anything else, I think we want to make sure that if you're in a company, make sure that put an effort to, if the firewalls are good, there's a virtual private network way of entering. Even VPN, I hear this is virtual private network. These days are not very reliable and they could have issues. So I do know of different things, but I'm definitely not an expert on this topic. So I'm going to say, maybe all I know is some of the common sense things, which is not to put everything easily accessible and so on, especially classified data.
Thank you.
Okay, is that good?
These are some of the questions we have received from our participants.
Okay.
So now I will request Engineer Mr. T.V. Kamalakkannan, Chairman CSI Chennai chapter, for formally proposing the vote of thanks. Kamalakkannan, sir.
Sir, Sarah is not able to join.
Okay.
This is Akila, Secretary from CSC Chennai chapter. I would like to propose the vote of thanks. Thanks for giving me the opportunity to propose the vote of thanks. First of all, I would like to thank the speaker, Professor N. Gautam, sir, for his wonderful session. It was a very thought-provoking session, sir. And I would like to thank especially our members, our chairs, HR Mohan sir, Dr. Sakthivel sir, and TV Kamalakkannan sir for organizing webinars like this. I thank all members of CSI, ACM, and IEEE CS for providing the necessary support and be present today. And special thanks to Kalai ma'am for live sharing, live YouTube live streaming, and also for recording the session. Last but not least, I would like to thank all the participants for their active participation and questions. Thank you, one and all.
Thank you, madam.
Thank you.
So now you can log out, sir.
Thank you very much.
Thank you very much, sir. Thank you.
Thank you so much, sir.
Madam, log out பண்ணிரலாமா?
Yes, sir. I will stop the